Hello everybody. Today I'll be solving DeepML problem number 7, matrix transformation. Our task is to write a Python function that transforms a given matrix A using the operation T inverse times A times S, where T and S are invertible matrices. The function should first validate if matrices T and S are invertible, and then do the transformation. If there is no solution, return 1, negative 1, sorry. So, there are a couple steps to this. First of all, notice that A, T, and S can be Python lists, NumPy arrays, or torch.tensors. So, first step is to convert inputs to tensors. Second step is checking if T and S are invertible. And I put underscore T after it because that's the signature for what they'll be when they're converted to a tensor. And the last thing to do is the transformation. So return the transformed matrix. So let's convert them to tensors. Shall we? So we can say A of T is equal to torch dot as tensor of A, T type equals torch dot float. And we can just copy paste this for S and T. Put S here and T here. And that should work. Okay. Now let's check if S and T are invertible. So let's start with T. There are a couple conditions. First of all, if the number of dimensions, because I believe there must be 2 by 2 matrices, so if number of dimensions is not equal to 2, so dot ndim of the tensor not equal to 2, or if the first amount of rows is not equal to the amount of columns, so T of T dot shape 0 is not equal to T of T dot shape 1. So if row is not equal to columns, or if the number of dimensions is not 2, and if the amount of, I believe 0 dimension is columns, so amount of columns is not equal to the rank of the matrix, which is for example, a 2 by 2 matrix, the rank is 2, but if the first dimension, number of columns, is not equal to the rank, then it's not invertible, because it's not the same number of rows as columns. So if that for columns is not equal to torch dot linalg dot matrix rank of the tensor dot item, because we want to return the scalar, the number, like the shape 0 returns the number. So if both of those conditions are met, then let's return torch.tensor of -1. And we can copy paste that and do the same for S of T. Okay, that's the checking done. Now we can return the transformed matrix. The transformed matrix is done by T inverse, then matmul A S. So torch dot linalg dot inverse of T, and then at is the symbol for matrix multiplication in PyTorch. So at A of T, at S of T, and it should be correct. Yep, and it meets both test cases. Okay, hope you enjoyed. As always, solution code is in the description. Thank you.